Hey, a warm welcome to day 47. Today we're going to continue working on our student management system app. So far we have created 3 windows: the main window, this one here, which corresponds to the main window class, the insert dialog, which corresponds to this class, and the search dialog, corresponding to this class. So we have 3 classes, 3 windows. Today you will learn how to add a toolbar to the main window, a status bar, an edit dialog, a delete dialog, and an about dialog. This will give you an all-around knowledge, a skill set that you need to build any type of GUIs using PyQt. So let's begin. This is the last day of PyQt. Let's do this. See you in the next video. Hi, in this video we'll add a toolbar to our app, to the main window of our app. So the toolbar we want to add will look something like this. So it will have 2 elements: an add student button and a search student button. Now both these 2 can also be accessed from the menu bar. So we have the file add student and edit search. So always the toolbar contains buttons which are basically shortcuts of the items in the menu bar. So the industry standard lays out that you want to have all the actions, everything that users can do in the app, you want to have everything in the menu bar. But it's also good to have some of the most commonly used features laid out here in the toolbar. So we'll add the add student button and the search button. Let's do that. So we're talking about the main window class. And let's go down here. To create a toolbar, you use the QToolbar class, which is a class that needs to be imported from Qt widgets. So that's also a widget. QToolbar is imported and here it is instantiated. So that will create a toolbar instance. And then you can apply methods to that toolbar, such as toolbar.set movable, and you set it to true. So that will make the toolbar movable, so the user can move it around if you want to do that as a programmer. And then you want to add the toolbar to self. Self is the window. So this is self, the window, and you want to add the toolbar using the add toolbar method. So that method gets a toolbar instance and adds it to the window instance, which is represented by self. Now if I run this script again, so let me go here, run 2 times, you should see something has been created. So there is a toolbar there, but it doesn't have any elements, so we need to add those elements. To add an element to the toolbar, so let's write a comment here first. Create toolbar and add toolbar elements. To add elements to the toolbar, you want to refer to the toolbar variable .add action with capital A. So that's a method that gets as input. Well, this is pretty easy. We don't have to write any additional code here. We do already have these actions, so we created those using QAction. So for example, we have the add student QAction, which is accessed from the file add student menu bar, so from the menu bar. So the menu bar is using this, but the toolbar can also use this add student action. So we get that variable which has this QAction instance. So copy that variable and provide it to add action. So it's quite intuitive. Now if you run this, you'll see that you have add student there. However, this is not the best practice. You want to have an icon instead of the name there. To add an icon, you first want to go to the lecture resources and download the icons.zip file, extract it in a folder, and then you'll see that there is an icons folder inside. So you want to copy that icons folder and you want to paste it in your root directory, in your project root directory. So there we go. press on add. So there's my icons folder. It has two PNG files, add.png. This will represent the add button in the toolbar, the add element, and the search button in the toolbar. So add.png, search.png. Now you go to the code again, you locate add student, and here in front we want to add another argument. This will be a QIcon class, so you want to instantiate that class QIcon, but first you need to import it, and that comes from pyqt.qt GUI import QAction, QIcon. And then go back to here. So add student action is equal to QAction, QIcon, and inside QIcon you simply pass the path as a string, the path to the PNG file. So in my case, and I suppose in your case as well, it is icons dot, so let's see the actual file name, add.png, or you can click over add.png on PyCharm and you can go to copy path reference, and you want to go to path from content root. So you click there, and so this makes sure that you are not doing any typos, and you paste that inside the quotes here, icons add.png. And yeah, that's it. Let's run the code and see. Yeah, that's the icon. And if you click it, it does exactly what file add student also does. So it shows up the insert student data, and here you can insert a new student record. So it's working fine. Let's add the other icon as well. So that would be duplicating that with Ctrl D or Command D, and then this is not add student action but search action. So search action goes there, and then you want to modify the QAction call. So the first argument we said it is QIcon, and that would be icons search.png in quotes. Let's run. There we go, that's the search icon, and it allows you to search for students in the search dialog box. So that's it. There we have a toolbar, which is movable, by the way. You can place it here and place it back there. As a bonus, before we close this lecture, I'd like to go here and do self.set minimum size and set the size to 800, 600, for example. And this allows me to view the window size bigger. So the window now has a minimum size, so I don't have to expand it every time I open it. There are other methods as well to set the size, but this is just one of them. So that was about adding the toolbar to the window. Thanks a lot, and let's add the status bar in the next video. See you. Hi, in this video you'll learn how to add a status bar to the program. The status bar is this strip here that you see, and it usually contains data about the current status of different elements of the program. For example, you may, as a programmer, you may want to display the current number of rows in the table or the current value of the selected cell in the status bar. So usually what you display there is text, but sometimes you may also have to display more interactive features such as these two buttons. In fact, these two buttons will show when the user selects a cell in the table. So normally they'll not be shown here, but once a cell is selected by the user in the program, for example, let's say the user selects this cell, then those two buttons will be displayed on the status bar so that the user can edit or delete that particular entry, that row or cell of the table. So let's do that. Let's add a status bar. So that was the toolbar up to here. Now let's add some more code, create status bar and add status bar element. Status bar is equal to, the toolbar was Q toolbar, the status bar is Q status bar. Let's go ahead and import it from Qt widgets. So that's the status bar. And then we want to add it to self, set status bar. So that is status bar, this variable. And if we run the program now, we should see this strip here. So that gray area is the status bar. Now, to add elements to the status bar, you want to refer to the status bar dot add widget. So this expects a widget now, for example, a label. Let's say hello is equal to Q label. Hello there, for example, and then you provide the hello variable here, which symbolizes the Q label instance. And of course, you can duplicate that to add more widgets. So let's say hello world here. And if I run this, you're gonna see we have two elements, hello there and hello world, in the status bar. Of course, the text can be dynamically generated from somewhere else in the program. Perhaps you get this from an SQL query where you get the number of students in the database and then you provide that result here as a string and so on. But our interest is to show some buttons here instead of labels. So I'll delete those and see how we can add some buttons. So we want to add an edit button and a delete button. But we want to show those buttons when the user presses or selects a cell. So when they click on a cell in the table, then we show those buttons. So therefore, we first want to capture the click. In other words, we want to detect a cell click. And to do that, you want to refer to the table, self.table, and then you want to access the cell clicked.connect. So cell clicked is a property of table and connect is a method of that property. So what do you want to do when the user selects a cell in the table? Well, we want to execute a method such as cell clicked without the parentheses, so just the method, just mention the method there, referencing to self, to the actual class. And so then you want to define a method here. So we're still inside the main window class, right? That's init, that's load data, insert, search. So I'm just folding them, I'm not deleting them. So we want to write define cell clicked, right? Was it that name? Cell clicked with self as argument. So when the cell is clicked, we want to generate an edit button, which is equal to Q push button, and give it a name such as edit record. It makes sense. And when edit button is clicked, we connect it to self.edit, which is going to be yet another method. So let's add that method below the search method, right? Make a break line, define edit self, and inside edit we want to create a dialog, right? Just like we did for search, we created a dialog. This is going to be edit dialog, and then dialog.exec to execute it. So that means we need to create a class edit dialog now, which inherits from QDialog. So that's the same thing that we did with insert dialog and other dialogs as well. And inside edit dialog, now we want to generate that dialog, which is going to look like this. Is the insert dialog. We did that already. That's the edit dialog. So we want to add these three there, which is basically like the insert dialog box. So for now, I'll just write pass, and I'll complete that in the next video. So for now, we want to focus on the status bar. Let's run the code as it is now and see when we clicked one cell, we should expect the edit button in here. It's not there yet because we haven't added the button to the actual status bar. To do that, we want to refer to self. Self is the class, the window, the main window. And then we want to refer to the status bar variable of self. However, this is just a local variable for now, so let's turn it into an attribute, self.statusbar, and make sure to turn that into an attribute as well. And then here you say self.statusbar.add widget. So before we added a QLabel widget to this method, now we want to add an edit button widget, which is also a widget, right? Edit button. And let me quickly duplicate this with Ctrl D or Command D, and this time I want to write a delete record button. So delete. This is a delete button, right? Q push button, delete record. When clicked, we want to execute self.delete, which is also a method we need to add. So let me just duplicate this method, and this will be delete dialog, which also needs to be created as a class. Delete dialog, Q dialog. And for now, let's just pass. Right. So here we are. We created an edit button. We created a delete button. We added the edit button to the status bar, and let's add the delete button also to the status bar. Now let's run and see what happens. So whenever I click a cell now, the buttons are added and they keep being added to the status bar. That's something we'll fix, but at least we do see the buttons added in the status bar when we click a cell. Right, so how do you remove them so that you don't have those duplicate buttons? Before you add any buttons, before you add the buttons to the status bar, you want to clean any other current buttons. For that, you want to do self.find children, and you want to find qpush button. So these types of children, so to say, and you want to save that result into a variable, and then you say if there are buttons, so if children, then you say for child in children, self.status bar, so that's the status bar, right? This one in here, dot remove widget child. So we remove that Q push button if any is found. If I run this now, I click on something, click on something else, now we only have these two, right? Currently this simply shows an empty dialog window because this is being instantiated, this class, so this generates a QDialog, but it's empty for now, so we need to populate it with actual widgets. So that's how you add a status bar. That's the code here. And if you want to dynamically add other widgets to that status bar, then you want to connect it to a method, self.cellClicked in this case. So that method is executed, and there you can write conditionals and generate widgets when something happens. So that's about the status bar. Let's build the edit dialog box in the next video. Thanks a lot. Previously, we added a status bar to our main window. The status bar will show two buttons when the user clicks on a cell: an edit record button and a delete record button. When we press edit records, an empty dialog box shows up. So in this video, we want to add the elements, the widgets, to this dialog window. Let's do that. So we have main window, and then we have edit dialog, which currently only has a pass statement, so nothing is happening here. So let's add some code, such as define an init methods as usual. This is where we construct those widgets. Now this edit dialog will be very similar to the insert dialog, which is constructed down here. So there it is. Therefore, what I'll do is I'll just copy this method, so the init method, I'll fold it. So if I just double click here and I select the folded line, you see the plus here. So if I do Control C now to copy that, and I just go here and I just replace this, so Control V, what I've just done here is I pasted the entire method, so I can expand this, and there it is. So that's the init method, which for now it's identical with the insert method, so we want to modify it. For example, we want to call it update student data. The width and the height are okay. Then we have the vertical layout, that's fine. Then we have the name of the student, and currently this text box is empty. You see there's nothing inside QLine edit. This is just the placeholder. Don't confuse this for the name of the text box. So perhaps now with the edit dialog, perhaps we want to show a default value in the box. In the insert dialog, the box was empty, but with editing, we want to play the game differently, right? We want to show the existing value for the selected cell for the user. If the user selected John Smith, then here we want to show John Smith. That will be displayed as the default value. So how can we get the student name and place it inside these parentheses here? Well, to get the student name, we should get access to the table first. And the table is part of the main window variable, right? Main window.table. Main window is the variable that we assigned at the very end here. So main window is equal to the instance of the main window class. The main window class has that table attribute. So we access the table and we get the current row from the table. And this method will return an integer. And we store that integer in the index variable. The integer could be 0, 1, 2, 3, depending on what cell the user has selected in the table. So if the user selected Michael Johnson, which is in the third row, then index will be equal to 2, because the first row has an index of 0, the second has an index of 1, and the third row has an index of 2. So index will be equal to 2. Now, what do we do with this index? Because this is just the index, right? But we want the student name. To get the student name of the selected row, we want to refer to the table again, so main window.table.item, in parentheses, we say index 1. Index is this, so we specify the index of the row and we specify the index of the column. So the first column is the ID column and it has an index of 0. And the second column is the student name column. It has an index of 1. That's why we place 1 here. And you also want to apply the text method to extract the actual text, so the actual student name string. And that string now, student name, is placed inside QLine edit. Paste it there, the student name variable, and yeah, we should be ready to go now with the next widget. So let's check this one first. Let's say get student name from selected row. So there we go. Let's run. We should get an error. First, I'll explain you why. When we press edit record, what happens is we get this error. So in line 125, so that's here. So this is the edit dialog, right? The init method of the edit dialog. This is the code we copy pasted from add student. So this code still has some methods referring to the old code. So this is add student. We want to change this to update, self.update, which is the method we'll add in just a bit here. So let's add that method, define update, or maybe you can say update student, update student. This is the method which will access the database and actually alter, update that particular row in the database. So let's just pass for now. And yeah, let's run again. So let's edit John Deere. Yeah, there we go. So John Deere now is placed as the default value of the QLine edit box. Now we go to the next combo box. The combo box has biology as the default value. As we did with the first widget, for this one we also want to select a default value, right? Let's do that. So we go to the edit dialog class in the init method, and before we create the combo box, we want to say here course name is equal to main window.table.item index 2. So this is the same code as this one here, where we extracted the student name. The only thing that changes is the index of the column. So we want the third column, which is the course column, and it has an index of 2. And we extract the text out of that. And then this doesn't go here, but it goes after we add the items, the courses. So we have a list here, we add that list to the combo box. So the combo box is represented by self.courseName, right? And this is another variable. This is just a local variable. This is the attribute. So these two are different entities. Don't confuse that, right? So then we say self.courseName, so the combo box, and we access the set current text method, which expects a string, and the string is course name. So there we go, and that should select physics for Andy Johnson, for example. So physics was the course and Andy Johnson is enrolled in, and that is the selected default item in the combo box. Yeah, lastly, let's do the same thing for the mobile phone. So that's for the mobile phone. So that's the same code, should be the same code with student name as well. So again, before QLine edit, we do mobile is equal to main window.table.item index 3. dot text with parentheses, and mobile goes in here. Right, so now we have the structure completed, but what happens when the user presses register? So when the user presses register, what we want to do is we want that the current values, let's say the teacher wants to update the phone number of this student. So they will write something like 12300 and they press on register. These data, Jane Crow, astronomy, and the new number should update the existing row in the database for this particular student. So let's implement that. So there we go, that's the register button. Perhaps we change it to update, it makes more sense. And so this button will trigger the update student function, so it will call this function, this method. And in this method now we want to establish a connection to the database with SQLite 3.connect database.db. Create a cursor object because we want to modify the database connection.cursor, and using that cursor we execute an SQL query. Earlier in the code we used a select query to search for existing records. We used an insert query to add a new record to the table. Now we want to update an existing record. So we want to say update students, the name of the table. And we want to use the set command. We want to set the name value, so the name column, to a question mark, comma, the course column to a question mark, comma, mobile to a question mark. And here we don't use a comma, but we say where ID is equal to a question mark. That's the query. So what this query will do is it will find the row where the ID is equal to a particular value, which we'll provide in this tuple. So these are placeholders for now, the question marks. So we will match that row with that ID and we will change the name to a particular value, which we also provide here in the tuple. The course will be changed to a particular value and mobile as well. So where do we get all these four values? We have 4 question marks, 4 values. Well, we'll get all those 4 values from the user, right? So when the user is in this dialog, perhaps they changed something like the phone number. They changed the phone number to 100. Maybe they changed the name to something else. So what we need to do as a programmer is we need to capture the current values in these boxes. So the values at the time when the user presses the update button. So John D, for example, 100 here. To do that, we need to look at this self.studentName QLine edit instance, right? We don't need the student name variable, but the self.studentName instance variable. You should be able to tell the difference because student name is only the existing value of the student, the existing name of the student selected in the table. So if the user selects Jane Crow, student name is equal to Jane Crow, right? But then that student name variable will keep having the Jane Crow variable. If the user changes something here, student name will still be Jane Crow. So we shouldn't be working on that, we should be working on this. So we should access that self.studentName. So we go here. Let's put this tuple in here. So we say self.studentName. So that gives us the text box, the QLine edit object, and we want to extract the text out of that, right? So now the text that the user enters in that edit dialog box will be stored in this expression here. And that expression is going to be injected into this question mark. So name will be equal to that value there, right? And we should do the same for self.course name, right? Dot text. And then is the next one, mobile. So you should respect the order of the column names that you set here. So student name, course name, then self.mobile.text, right? So double check these. Self.course name, yes, there's an actual attribute for the combo box, and then we have the mobile, self.mobile, that's also fine. Then we have the other placeholder, the fourth one, that is the ID. So let's make another comma here, and I would like to actually split this because it's getting too long. So that's the fourth item of this tuple. So the fourth item will be the ID. How do we get the ID? Well, the same way we did to get the student name, the selected value of the cell, right? Student name. So let's add another line. Get ID from selected row. So that would be student ID is main window dot table dot item index 0. So the ID column has an index of 0, and we get the text out of that, right? So that's the student ID, and we need to access that student ID from a method. Therefore, let's make it an attribute of the class. So then we can say self.student ID, and that's it. So the ID is something that doesn't change. In this model we're working on, the idea is to have a permanent ID for students, and every new student that is added to the database, you want to assign them a new ID that has not been used by others in the past. So that's the query, and before we execute, make sure to commit the changes. So when you do a select query, you don't have to commit because that's not a write operation, but update and insert are write operations, write database operations. So you want to commit, and you want to close the cursor, and you want to close the connection. And you also want to refer to the main window where the table is. So the main window class, and you want to call the load data method of main window so that you can refresh the data of the table so that you can see the changes that the user just made. So let's go back to our class, edit dialog. We were inside update student. So main window dot load data. So just call that method. Maybe a comment, refresh the table. And let's execute. So let's change this student. Go to edit. Let's change the student's phone number. This time it starts with 102345. Press on update. And yeah, we've got an error. QComboBox object has no attribute text. So the error is in this line, 140. So there we go. Yeah, text is an attribute of a QLine edit widget, but not an attribute of a combo box. For combo boxes, so self.courseName is a combo box object, Therefore, we need to apply an item text method, and inside that we want to provide self.course name again dot current index method. Let's split this as well, and I'll split all these 4 items, so each of them in one single line. That's more readable. And let's run again. Right, so that student we want to update with a new phone number 102345 update. And we can see that the mobile phone is updated accordingly. So it seems to be working fine. Let's also change the course of the student to math, and math is updated as well. So things seem to be working fine, and that's how you edit data in PyQt6. So that was quite fun, I suppose. Thanks for following, and let's add some more features to the program. See you in the next video. Previously we implemented the edit record feature. In this video we will implement the delete record feature, so that when the user selects a record and they press on delete, then here we want to show a confirmation message such as, are you sure you want to delete? And then we have 2 buttons here, yes or no, so that the user can press yes if they want to confirm the deletion, or no if they want to continue without deleting that record. So let's do that. Currently we do have this empty dialog box. That's because we did create like an empty class here. Note that I've folded the other classes. The code is still there, but I'm just hiding it. So that's the delete dialog class. It only has a pass statement for now, so please write this class as you see on my screen if you don't have this already. And moreover, we also have in main window, we also have the call for that class. So the delete method is part of the main window class, and this delete method is instantiating that delete dialog, which is empty for now. So delete dialog is this class. This is empty, so let's write some code in the delete dialog. So the init method of this class will be similar to the init method of the edit dialog class. So let's copy some code here. I'll get the first lines up to fixed height, up to this line, and go down to delete dialog. Paste those lines in here. So this will be delete student data. But then the edit, let me fold this also, the edit init method is creating a QV box layout because we had those widgets stacked vertically. In this case, this would be more appropriate to have a QGrid layout because our widgets are stacked horizontally and vertically. So the message will be on top, and then the buttons on the second row, one on the left and the other button on the right. So yes or no. And then let's start creating the widgets. Let's create a confirmation message using a QLabel class. Are you sure you want to delete? That's a standard confirmation message you show to this kind of confirmation dialog boxes. And then we want to have a yes button, which will be equal to a QPush button widget, having a yes label, and same goes for no. QPush button no. And then we add those to the layout using an add widget method. So that would be the confirmation message first on top. So that would be row 0, column 0, expanding 1 row, expanding 2 columns. You'll see how that will display in just a bit. Layout add widget, that will be yes button. Second row, so index 1, first column, layout.add widget no 1 1, first row, second column. And we do self.set layout, and we set this layout object as the layout of the delete dialog window. Right, so that's the GUI. Now we still need to implement the functionalities so that when the user presses yes, something will happen. But let's see if we've got this right so far. Are you sure you want to delete? Yes, no. The sizing is a bit off, so to fix that, you simply want to remove these two sizing setting lines, and that will use a minimalistic dialog window, which is the case for these kinds of confirmation windows. So are you sure you want to delete? Yes or no? If you press yes, for now nothing happens, but we can handle that using yes.clicked.connect. When the button is clicked, we want to execute a delete student method, which will be a method we will add inside delete dialog. So define delete student. Now in delete student, here is where we write that SQL query which will delete the selected student record. So similarly as in edit dialog, we're gonna get the student ID. So here we are inside init. So the student ID can be accessed using main window.table.item, giving the index, which can be accessed through this line. So we are trying to get the index and the ID of the currently selected row in the table, right? So if the user, I cannot run the code now to show you the GUI, but when the user selects a cell, then we want to get the ID of that selected cell. So let's copy these two lines, that one and this one. First we get the index, go to delete dialog. Don't confuse it with this method, so be careful where you paste that. So paste it inside delete student. So we get the index. Now you could also paste it inside the init method, so either way is fine, right? But let's just keep it in delete student this time. And then you get the self student ID. Let me copy it together with the comment. And we go inside delete student. Let's put this comment up here. Get index and student ID. Get selected row index and student ID. Yeah. So now this student ID, since this is part of delete student, we don't need the self. If you placed it inside init and you access it from delete, then you'd need to do it self.student ID inside init, and then you access it with self.student ID from within delete student. But now we can keep it as a local variable, and then we're ready to establish a connection to the database. With SQLite 3.connect, that is the database.db file, create a cursor using connection.cursor, and using that cursor we execute an SQL query. This will be a delete SQL command from students where ID is a question mark, and in this place it's gonna go, so make two parentheses, this should come as a tuple, so here goes student underscore ID. Also make a comma here so that this is actually read as a tuple by Python. Otherwise, if you don't have a comma, this is just a value inside parentheses, so this is not a tuple if it doesn't have at least a comma. Right, then connection.commit, because this is a database write operation, so you should apply the changes. cursor.close and connection.close. And then you may want to access main window .load data. Main window is the instance representing the main window of the application, and we want to load the data of the table. We want to refresh the table. Let's run this. Let's delete John Deere. We go to delete record, we press on yes, and we've got an error. Oh, I've got a typo here. The table name is students, sorry. Let's try again. John Deere, delete, yes, and John Deere disappears. But this window doesn't close. That's not the good practice. We want to show like a prompt that tells the user that the record was successfully deleted, right? Let's do that. So we can simply do that first by using self.close. We want to close the current window, the yes or no window, and then we make a confirmation widget, which will be equal to QMessageBox. This is a class which you need to import up here from Qt widgets, QMessageBox. This is a simple window which creates, so we're inside delete student, so this creates a simple dialog box. Actually, QMessageBox is a child of a QDialog box. So in other words, this is like a simpler dialog box that allows you to do simple things like, you know, just showing some simple success confirmation or things like that. For example, we can say confirmation widget.title. We set the success title to that window we are creating. And then you access that variable again, and you can access the set text methods. And you can say the record was deleted successfully. And then you want to execute that. Let's see what we've got. Let's delete Jane Crow. Press on yes. We've got an error that says QMessage object has no attribute title yet. That actually is set window title with capital T. Let's try again. John Smith this time. Delete. John Smith is deleted, and we've got this window. The record was deleted successfully. You press OK, and yeah, that's how you do that. We have one more lecture to go, and that will be to implement the About page to show some information about the application. And we can mark this app as completed. So thanks a lot for following. I'll see you in the next video. See you. Hey, welcome back with the last video. In this video, we will implement the About item here, so that when the user presses this, we're going to show a message box showing some information about our program. So let's do that. First, you want to find out where you have written, where you have created that About Q action. In my case, it's in line 24, so that's the main window class, right? So go to main window in the structure here, and then go and locate the Q action, which gets about as a string, as an argument. So we create the Q action there, and we add that Q action to the help menu item, right? That's the help menu item that I just showed you. You go to help, and then you go to about. This line is needed for those who are on Mac computers. We've written this line earlier, but now what we want to add is we want to connect the About action object to a method. So we want to say .triggered. So when the user triggers that, when they click on that About item, we want to connect it to a self.about method. So inside main window class, we want to add an about method. So we have a delete method here. Let's add an about method as well. The about method is going to create a dialog box. Let's call this about dialog, and then execute it here. So this is going to be a class which we'll write just here, class about dialog. Now, since this is a very simple window, we can inherit from QMessageBox instead of inheriting from QDialog. We did use QMessageBox earlier with a delete dialog box, so the confirmation that the record was deleted, that confirmation prompt was created using a QMessageBox. You can see it in delete dialog, this one here. So, but here, what we did here is we simply instantiated this. We didn't create a class which inherited from this, which is fine. So either way is fine, but inheriting from that keeps the code more organized. So that's what we're doing here, inheriting from that. And so then we have to write an init method, call the init method of the parent, set a title using set window title, such as about. Write some content first. So this could be like multiple lines. You can write something like this app was created during the course, the Python mega course. Feel free to modify and reuse this app. Yeah, that should be fine. And then you do self.set text, and then you say content. So compare this to the other code we used with a delete case. So here we are calling set text from self, but in delete, which is here, we're calling set text from confirmation widget. So confirmation widget is the variable that holds the QMessageBox instance, but now self is the variable that holds the confirmation box instance. That's what happens when you inherit. Right, let's try. Run the code, go to help, about, and yeah, that's the window. There are other ways you can format this better, but I'll leave that to you. So that's enough for this app. I believe it was quite a long one, but it's quite fun to build. I hope so for you. That was the case too. Thanks a lot for following, and yeah, we have more apps to build, so I'll see you in the next ones. See you. Hey, welcome back to this special video on the programming skill of the day. The programming skill of the day will be refactoring. We've talked about refactoring just a little bit here and there, but I want to clarify what refactoring is, when you do it, and how you do it. So let's begin. We're going to use the code we wrote today. So that's a complete app, the student management app. So let's answer the first question about refactoring. What is refactoring? Refactoring is the process of improving the structure of existing code, like this one here, without changing its functionality. So that means whatever we change here, the code should work the same after we refactor it. So why do we refactor? Why do we change the structure? Well, we improve the structure. For example, there are some things called code smells. So when the code smells bad, for example, if we have duplicate code, let me find an example. Let's say this here. Here we are connecting to the database.db file, and then we do that again here, somewhere in here. So in different classes, we're having the same code. This code smell it's not a good thing to have in your code, because, for example, let's say we want to change the name of this database.db file, or we want to create a new file, and then we'll have to update all the occurrences of database.db in the script. And this is where refactoring comes in. So in this case, to fix the code smell of duplicate codes, so duplicate code is one of the code smells, to fix this code smell, we could do something like we create a new class here, class database connection, right? And this class would be responsible for creating a connection to the database. And then all these classes will use an instance of that class. And so we would only have to mention database.db only once inside this class. We're going to do that right now. So let's implement this class. So this is one of the code smells. Duplicate code. I'll mention more code smells, but let's do this first. So we have this class, and this will get a database file as input. And now we give this a default name of database.db. So then we'll not have to mention database.db in any other place in the code. And then here we say self.database file is equal to database file. So we create an attribute of this class, and then we have a method defined connect where we establish a connection. So the connection will be SQLite 3, which is actually the same code as we have in any of these classes. For example, here we establish a connection to the database. So let's paste that there. And now instead of database.db, we'd say self.database file, right? This attribute goes here. And then we return the connection. And then we go to each of these connections. For example, here we are inside main window.load data. And then we say connection is equal to database connection with parentheses. So we need to call that class. And then you can just say connect here. So that will return a connection object. Right, so now I'll get this code and I will paste it here as well. Right, so we still have some degree of duplicate code, so we have to reuse this code, but that's unavoidable. What we're avoiding here is having to write literal names such as the string database.db. Now you can avoid this by just like having a main connection on top, just having a variable connection, and then having all the classes refer to that connection, like the class that inserts students referring to that connection, the class that updates students, but that means you're not closing the connection before you're entering the students, so you'd end up with an open connection object which would be closed only when the program is closed at the end, when the user is done with the program and quits it. So that's not the good solution here. You want to have a connection established and closed for each of these classes. So let's keep using this code here as well. Here as well. You'll see how this comes in handy in the next day, tomorrow. Tomorrow we're gonna be implementing MySQL in this code. And so for that we can just change the one single class, so the database connection class, instead of having to rewrite code over and over again in each of the classes. So that was about the duplicate code smell. So we fixed that. And of course you want to run the program just to test it if things are working fine. Let's try to enter a new student like that. Register, and the student is added correctly there. Let's try to edit. Add an S to the surname, update, and it's update it accordingly. So you can make more tests, but that's about refactoring, and that's about the duplicate code smell. Now, as a programmer, using your experience, you might be looking for more code smells, such as long methods, for example, methods which are very, very long. Like, these are fine, but if it's like 100 lines of code, then you might be looking at having different methods. So splitting that code into different methods. So that would be another code smell. Another code smell is unclear names, names which are not readable. Let's say this name here is fine, so you can understand by just looking at the name of this method, you can understand that this actually loads some data. But if this was a bad name, then you might want to refactor it. So in this case, it's better to use the refactor function of PyCharm, and you do like rename here, and that would rename not only this occurrence of the name but also other occurrences in the code for this particular method. You cannot always use the refactor function of PyCharm because some refactorings are a bit more complex, like the one we just did, where we created a class with a connection, with a database connection. But for other simple refactor processes, like renaming something, you should always use this option here. Part of refactoring is also adding comments. So code that lacks comments, if you think that the code should benefit if you added some comments, then in the refactoring process you can add those comments. So that does not change the functionality of your code. So in this case, I think we could add some comments on these methods. So that's something you could do on your own. But I just wanted to let you know that uncommented code is also a code smell that you need to fix by refactoring it. Another code smell is inefficient algorithms. So if you're doing some heavy processes in your code, if you have code that does something heavy, then it's important to have a closer look at that code and see if you can make it faster. So you're not changing the functionality of the code. The output should be the same after you refactor it, but fixing that algorithm will improve the speed of the code. So that's also part of refactoring. And so yeah, these are the main code smells that you should look at your code after you write it. So after you complete your app, you should go over the refactoring process. I hope this video makes sense, and tomorrow we're going to be working on MySQL. Thanks for being my student, and I'll talk to you tomorrow. Thanks.